as an exceptional point, friends, an exceptional point, the point is a lot of you are doing everything exactly as you're supposed to do, and then you press zoom 9 and nothing happens. Remember, we had you turn the plot off on the last problem. You got to turn that bad boy back on. And the easiest way to do that, you can always go through the booklet, stat second y equals stat plot on. But the easiest way, honestly, is to press the y equals button and just highlight plot 1. Then it's back on. So your choice. The booklet always will work for you. But there are little shortcuts you'll learn as you use the technology more and more. And we plan on doing this more and more. I definitely want to do this more and more. I don't know. Press zoom 9. Does it look kind of like this? Well, there you go. Yeah, it's interesting. If you have the wrong window and you plot the data, it's going to look vastly different. Frankie had a cool window. She just had a window where it looked, you used the old window. So if you had the window, it was like 1 to 10 or something like that, and then it went something like 30 to 50. And, well, actually, it wasn't. Obviously, it wasn't because it's not there. But regardless, unless we all have the same window, it's going to be looking vastly different. So I love looking at this because what appears to be true about Math Bachelor ticket prices from '83 up through 2007. That keep going up. Looks like linearly. Isn't that interesting? It almost looks linear. And it's even more interesting because as you get towards the end, in the beginning it's almost perfectly linear, like $1, 2, 1, 2, 1, 2, 3, 2, none, 2. I mean, it's essentially averaging out to about $1.50-ish somewhere there per year. And then it's, you know, obviously there's some jumps back here. You see the gaps where we omitted 2001 and 2003. The gaps are right here. But you can almost see where they should be based on that model. So let's do that first. Let's reverse engineer how much a ticket price should have been in '01 and '03. Shall we? Let's reverse engineer. First of all, let's take some guesses. What do you think it should have been in 2002? I'm guessing between 43 and 44, maybe 43 and 50, yeah?
43.
How about in 2003? Maybe 47, somewhere in that ballpark, yeah? Right? Let's use the model to do it for us. First of all, get the model, yeah? First of all, get the model. So you're going to go, this is all in the booklet, so I'm going kind of quickly, but it's all in your booklet. Stat, calc, lin reg. Oops, hit the wrong one, hit the wrong thing, sorry. Stat, calc, lin reg is 4, not 2. Make sure to stick it in Y1. That makes it easier to deal with later. If you go to Y1, yeah. So, what does that tell us? What does that tell us?
On average, it goes up to $1.50 a year.
Boom! Chelsea, on average, Bachelor is picking up $1.50 a year on their ticket price. On average. What's this 12 mean? Anybody?
That was the starting price.
Starting price when? Very nice?
80.
In 1980, if we extrapolated this thing backwards to 1980, assuming the same behavior, careful with that statement I just made, assuming the same behavior, it would have cost $12 in 1980. Now that's assuming that it reverses back to 1980 in the same rate. I don't know if it does or not. And I tend to ignore the y-intercept. I focus on the slope for sure. Slope's wickedly important. Y-intercept, not so much. It depends on where you call 0. If you call 1900 0, that price is going to be negative in 1900. For mathematical reasons, not for logical reasons. Cool? Good so far? All right, how can we use this to figure out what the ticket prices were in '01 and '03? Yes, we can use that value thing from before. May I turn off the scatter plot though? It makes it a little bit easier. I'm going to turn the scatter plot off real quick and just look at the model. The scatter plot just gets in the way because every time you press trace, it jumps to the plot. So once you have the plot, the most important thing about the plot was when you guys said what? What was the most important thing about the plot?
That it was linear?
When you decided, Michael, that the data was linear. Once you've decided it's linear, you run the regression, the plot really isn't even needed anymore. You don't even need the plot anymore. That's what's kind of cool about it. Good, 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 good. Okay, here we go. Second trace. Second trace gets you value. The X we want is, I think, 21 for starters. That's for 2001. Looks like it should be about $44.80. That's damn close to 44.5 you guys were telling me to use. Yeah, it's a little bit above the 45 and a half. That's just because the slope's a little bit underestimated on one side of it. Not a big deal. And now it's cool. You can just type 23 now. That command will keep running. You just type. You don't have to run second trace again. It'll just keep that command alive for a while. We said 47. It's almost 48 based on the model, but you know we're close. We're close. We're in there. We're in the range of estimates. Please, just Tony,
There
go.
seems to be, I'm just noticing, there seems to be a pretty good jump right after the Olympics too.
Nice. Look at that. Now he's micro-analyzing data, and I love that. Olympics was 2002, yeah? Salt Lake. I believe 2002 Salt Lake, right? Boom. All of a sudden, look at this.
Well, 04 to 05 is what I was looking at.
Oh, you're looking at these Olympics. I got you.
Because there's $3. We go back. 96 would have been when there's $3.
Sure. Now here's the deal, though, and this brings up. I think you bring this up actually. It brings up an interesting point. Bob Woodward, local guy in town, in Mountain Bike Hall of Fame, great dude, awesome. He's over he's like 110 years old. He still mountain bikes more than I do. Fantastic dude. He keeps posting pictures of old Olympic athletes from the 70s and 80s. And most recently, he was complaining about the lack of snow we have right now. And he put a bunch of pictures up from 1991-92. He's like, you see, Bend used to get a lot more snow. Used to get a lot more snow. I'm like, Woody, time out. 91 and 92 on record was the most snow Bend has ever gotten. If you actually track how much snow Bend usually gets, the mountain usually gets per year, it's a staggering amount. Now, Bend, on average, if you add up all the snow we get, is about 2.5 feet. On average. We are definitely below that right now, and I don't see any respite in the immediate future. But the problem is that you can't talk about 1 year where it was super great and say, you see, we used to get a lot of snow. Yeah, in 91, 92, you got a ton. But in 93, it was back to normal again. So you got to be careful. I like to look at that too, but I think it's more telling to look at the entire range of values and see how that gets absorbed.
Okay.
Speaking of absorbed, let's answer one more question, shall we? What should the ticket price be right now, based on this data? Based on this data. So in order to use what we just did, what are we going to have to do? We're going to have to go out to be able to absorb 33. Let's use 33 instead of 34. That gives them the benefit of the doubt as far as pricing. Okay, so let's use 33, but we can't do it right now, can we? It's going to give us an error, I think, because of that value problem, right? Let's try it. If I type in 33 and press enter, you see it's invalid. I've got to adjust my window to be able to accept 33. So I'm going to quit, change my window to accept. I'll go to 35. What the hell? Why not? Okay, there's the line, linearly. I feel better about this estimate than the previous insurance estimate because 04 and 13 are fairly close compared to the other one. All right, I'm going to type in value 33. 33 is right? Yeah, 33 years after 80. Here we go. Should be 63.5 bucks. Hang on. Now we have to adjust for some things here. Tickets. All right, here we go. Full day. Now, are they still doing the Bluebird versus whiteout versus rain pricing? Remember how they were doing that for a couple of years where you would pay more on a Bluebird day, you'd pay less on a crappy day? Are they doing that anymore or is that gone? That's gone now? That didn't last very long. That was like 1 or 2 seasons. Okay, here we go. Adult full season pass, 79 bucks. 79 bucks. We just estimated it should have been 63. This is about 15, 16 bucks over our estimate. Now you got to remember, our estimate is just that. It's assuming the behavior was going to continue as it was, yeah? Technically speaking, I should run that program to see if it's within the range of. Let me see if I'm not sure if it works for this. Let me just run my program real quick. Okay, I ran the regression. The input value was 33, correct? 33 bucks. Let's see if it works. Okay, by prediction, it should have been between 61 and 66, which means even allowing for uncertainty, it's still way the hell above what it should be, which means what? What do you think, Amber?
Well, between those years, they added a bunch of runs in the back.
Exactly. So they think now, because, and I'm not judging this, I'm just saying, that might be one factor going, you know what, you got more terrain now. Maybe what we should do, is reanalyze, I'm getting an idea for not a class exam or a quiz for you guys. Analyze the square footage of runs per dollar and see how that changes over time. Maybe that justifies the higher ticket price. Maybe. Maybe more runs equals more maintenance equals more upkeep. Perhaps. Perhaps. Chels?
Well, we're also getting ready for the Winter Olympics too. Is that a big thing?
I don't know. Maybe. This goes with what Tony was saying earlier.
Yeah.
So now you start asking questions. This is why statistics is great. Because now you ask a question. Wait a minute. Why the hell is it $79? I mean, late arrival is $67. Hell, the late arrival is even more expensive than the annual full day. even at the high end of our estimate, the late arrival's too much. So then you start asking questions, you're like, okay, so what the hell, what's going on? That's when you have to say, when you extrapolate with data, you've got to be careful. Even only going 6 years out, it's clear to me now, and I don't have the data from the past couple, but when you, let me back up here one, friends. These two words, interpolation, extrapolation, this means you're staying within the data. So when we calculated our ticket prices for 2001 and 2003, do you feel pretty good about those prices? Well, yeah, because they were within the pattern. Unless Bachelor did something like this in 2001 or this in 2001, which chances are they didn't. I feel pretty good about those estimates. But those are interpolated. I start getting nervous when we start extrapolating because that assumes the behavior is going to continue, and you can't guarantee. Past behavior does not guarantee future results. Everybody ever heard that phrase before?
Yeah.
They always put it on investment documents. Past behavior does not guarantee future results. They say, here's how the fund did the past 10 years. The idea is they want you to look at the past 10 years and go, holy crap, it did great. And then they say past behavior does not guarantee future results. So they want you to look at the past 10 years of behavior and be like, I want to invest in that. But I can't guarantee it'll actually do that. Wait a minute. See what I'm getting at here? It's a bit of a catch-22. But that's statistics. It's called probability. Because it's not certainty. Does that make sense? There's an element of unknownness, unknown to it. Cool? More on that on Monday. Check your email / and the schedule page. We're going to have to meet outside for part of Monday because we'll be collecting data on my bike running down the hill. Okay? I think we're going to go straight there to meet. I'm going to try to find a room in Pioneer Hall. So we can go to there instead of coming all the way down to here. So check your email / the schedule page. I'll do one or both if I can. I'll get it somewhere though. So check both email and schedule page for our meeting place on Monday, so you guys can time me on my crazy bike stunts. Okay, doke. Tony, what's up?
Say one more thing to throw in.
Yeah, please throw.
To next year's